What's the technical difference between a flash drive and an SSD? I was just reading a question on backups with flash drives, but I was not quite sure why SSDs would be better than flash drives for backups. To me, solid-state drives look like larger versions of flash drives. But surely there must be something that makes the former much more reliable than the latter. What's the difference between an SSD and just a regular flash drive? For example, do they both use NAND?
Both flash and SSD are based on NAND-based flash memory, which retains data without power, and so can be labeled as flash memory. Technologically, the main differences between the two are in the underlying technology used to construct the NAND, the quality of the flash memory controller, the computer connector, USB or SATA. NAND technologies. NAND technologies diverge on 2 points, speed and price. On the one hand, one finds MLC, multi-level cell, which is a memory element capable of storing more than a single bit of information. Most MLC NAND flash memory has 4 possible states per cell, or even more with TLC, so it can store several bits of information per cell. This reduces the number of required transistors, so reducing size and manufacturing costs, while also reducing speed and increasing the possibility of errors. On the other hand, one finds SLC, single-level cell, where each cell can exist in one of 2 states, storing 1 bit of information per cell. This increases the access speed, while also increasing manufacturing costs and electricity usage. An MLC cell is typically rated at 10,000 erase/write cycles, while an SLC cell might last 10 times that before failing. Because of these differences, MLC is typically used in slower and cheaper media, accessed typically via USB. A good SSD will use SLC and be costlier, but faster, have a longer lifetime and be typically accessed via SATA 2 or 3. Memory controller. A USB mass storage controller has only a small microcontroller with a small amount of on-chip ROM and RAM. An SSD controller is much more complicated. The controller is an embedded processor that executes firmware-level code and is one of the most important factors of SSD performance. Some of the functions performed by the controller include error-correcting code, ECC, wear leveling, bad block mapping, read scrubbing and read disturb management, read and write caching, garbage collection, encryption. In a hybrid SSD, the controller will also manage a small classical hard disk. Connector. A flash stick normally uses a standard USB plug that provides the physical interface to the host computer. These can now go up to USB 3 speeds for the more costly models, or USB 2 for the common ones. SSD technology uses electronic interfaces compatible with traditional block input/output, I/O, internal hard disk drives. Additionally, new I/O interfaces, like SATA Express, have been designed to address specific requirements of the SSD technology. Most SSD cards are typically much faster than classical hard drives. Summary. A flash stick typically has less memory capacity, is slower, cheaper and is also less dependable than an SSD. There are of course always devices that bridge these differences by using compensating technologies. References. Wikipedia Solid State Drive, Wikipedia USB Flash Drive, Wikipedia Multi-Level Cell, MLC, Wikipedia Flash Memory, Micron TLC MLC and SLC devices. MLC versus SLC, which flash SSD is right for you?
There are a few articles out there about the differences between SSDs and flash drives. SSD just means a hard disk that doesn't move. Flash is a type of memory that is very fast and doesn't require continuous power, non-volatile. SSDs used to use RAM, but now use flash instead. In short, you shouldn't compare flash to SSD just as you shouldn't compare batteries to lithium-ion. In both cases the latter is a type of the former. This URL.
Most SSDs use NAND, although better ones may use faster memory like DRAM. I think one of the biggest differences is simply that SSD drives are made to a higher standard than USB flash drives. Flash drives are typically used for data transport and short-term storage, so they don't need to be as reliable as an SSD.
If you want to support the channel, please consider